All of you, good morning. Today we are going to start the Unit 1 Basic Electrics Circuits Analysis. Right? In this, we are going to discuss about basic components of electrical circuits. Alright? So you can see this picture. These are the basic components of the electric circuits. That is like resistor, capacitor, and diodes, LEDs, inductors, and other ICs. Like this, we are having the components. So when we are dealing with the electrical circuits, these are the components will be there in the circuits, right? So here, first of all, we have to that is recall the basic things. Already you are already aware of this. So first one, the basic concept of electric current. It is nothing but the rate of flow of electrons is called current. So we can write it as current is equal to charge by time. That is Q by T. The unit for current is amperes. It is denoted with capital A. And then next one is the voltage or potential difference. It is defined as the potential difference between 2 points in electric circuit. So here the unit is volt and it is denoted with capital V. And next parameter is the power. So here the rate at which the work is done called as power, or the rate of usage of energy is also called as the power. The equation for this power P is equal to dW by dt is equal to, we can write it as dW by dt as dV by dt into dQ by dt. So that is equal to V into I, right? So here next parameter is the energy. The capacity to do the work is called as the energy. Energy is equal to power into time. The unit for energy is watt second, or it is also denoted with joules. And then we'll move on to the definitions of the network. So an arrangement of various electrical energy sources along with the different circuit elements is called an electrical network. That is, the assembly of devices and or equipments is called as the network. Next, circuit. An electric circuit is composed of individual electronic components such as resistors, capacitors, inductors, transistors, and diodes, connected by conductive wires or traces through which electric current will flow. In short, a circuit is a closed path through which electric current flows. And then next one is the network element. A network element or circuit element has two perfectly connecting leads ending at connection points. Example, in an electric circuit, the networks or the circuit elements are classified into two types: active elements and passive elements. First one is the active element. The active element or energy sources, that is voltage and current sources, which has the ability to supply energy to the network. So it delivers power to the circuit. Example, generators, batteries and all. And the next one is the passive elements. The passive elements consumes power. It take away the power from the circuit. The passive elements which make up a circuit takes energy from the sources and either convert it into another form or store it in an electric or magnetic field. So it dissipates the energy in the form of heat, and it stores the energy in the form of charge. Example, resistors, it will dissipate the energy in the form of heat. The inductors and capacitors, it stores the energy in the form of charge. Resistors dissipates energy in the form of heat, inductor stores energy in the form of magnetic field, and a capacitor stores energy in the form of electrostatic or electric field. Types of electrical network. So here we can define the electrical network in different ways. That is based on the linearity of the working of the circuit. We can call it as linear network or non-linear network. Now we will take it as linear network if the circuit parameters are always constant irrespective of change in time, voltage and temperature is called linear network. In non-linear network, the circuit whose parameters changes their values with respect to the time, voltage, temperature is called nonlinear network. And then depends upon the direction of the flow of current, we can classify the networks into bilateral network and unilateral network. In bilateral network, a circuit whose characteristics or behavior is same irrespective of direction of the current flow. That is, voltage current relation is same for flowing in either direction. Example, resistor. If the current is flowing in either direction, the both are same. And through the inductor and capacitor, it is same. A unilateral network, a circuit whose operation or behavior is dependent on the direction of the current through the element that has different relation between voltage and current for two possible direction of the current, like vacuum tube or diodes. That is, in only one direction the diode will allow the current to flow, but the current cannot flow in the opposite direction. So it is called as unilateral network. Type The next type of network classification is depends upon the elements connected in the network. That is, if the active elements are available in the network, it is called as active network. If only passive elements are there, it is called as passive network. As per the definition, active network, a circuit which contains a source of energy is called active network. That is, the source of energy is voltage source or the current source. The passive network, a circuit which has no energy, is called passive network. That is, it is having only resistor, inductor, and capacitor. The connection of passive and active elements by means of conductor is called an active network. If active sources are absent, it is passive network. Next, depends upon the components connected in the circuit. Physically connected in the circuit, we can classify this into lumped network and distributed network. In lumped network, a network in which all circuit elements are physically separable is known as lumped network. Most of the electrical networks are lumped network. That is, in this network, we can separate the resistor, inductor, capacitor separately. That is, physically we can separate these components. But in distributed network, we are having a single component which is having the property of resistor, inductor, and capacitor. We cannot physically separate this. It is called as distributed network. A network in which circuit elements are not separable for electrical analysis purpose is called a distributed network. Example, a transmission line has a distributed resistance, capacitance, and inductance along its length. Next, the types of circuit. It is short circuit and open circuit. If a circuit element is replaced by a short length of an ideal conductor, the terminals are said to be short circuited. Voltage across the short circuit is zero, regardless of the current flow through it. Mathematically, V of t is equal to 0, I of t is not equal to 0. So here you can see this in this network. Here the voltage source V is connected to the load RL through the resistance. Here we are removing this RL, that is the load resistance, and we are connecting this terminals directly. So here it is called a short circuit. Here the voltage across this will be equal to 0. Next one is the open circuit. The current in open circuit is always 0 because there is no connection, the current cannot flow regardless of the voltage across it. Mathematically, I of t is equal to 0, but the V of t is not equal to 0. Here you can see this, the two terminals of the circuit, that is RL, is removed. So there is no connection between this. So what is the voltage between the terminal A and B is directly reflected across the load terminals. In the short circuit, the wire is connected between two terminals. That is, if R is equal to 0, a no voltage difference exists and all points on the wire are at the same potential and current can flow as determined by the circuit. And in open circuit, there is no connection, physical connection, only the air is between two terminals. So here R is infinity, so there is no current flows. The voltage difference can exist as determined by the circuit. And the basic circuit components. The three basic circuit components are resistor, inductor, and capacitor. These are the symbols of the resistor, inductor, and capacitor. First, we will take the resistor and we will discuss in detail. The resistor is a passive two-terminal component that resists or limits the or regulates the flow of current in an electric circuit. It is denoted as capital R or a small r. The symbol is, this is the symbol shown for the resistance. The unit for resistance is ohms. And we can also write the equation of the resistance R is equal to rho L by A, where rho is the resistivity of the material and L is the length of the material and A is the cross-sectional area of the resistor. And the power in the resistor can be derived as follows. Power is nothing but the power dissipated in the resistor that can be given as P is equal to V into I. With respect to here, V is equal to I into R. We know that V is equal to I into R and I is equal to V by R. Therefore, on substituting this, P can be written as I R into I, that is I square R. In terms of voltage, we can derive P is equal to V square by R. And the energy in the resistor can be determined as the integral of the instantaneous power. That is for the time period. What is the power consumed? That is the energy. So W is equal to integral T1 to T2 into, that is integral of power dt. So here power can be written as I square R. So R is a constant we can take out. So integral T1 to T2 I square dt. It can be written as, also in terms of voltage, it is equal to 1 by R integral T1 to T2 V square dt. So otherwise we can also write it as, after integration, it is I square RT or VIT joules. Next, we will take the second component, that is the inductor. An inductor is a coil of wire that stores energy in the form of magnetic field. With a voltage applied to the inductor, the magnetic field charges up as the current passing through the inductor increases. The symbol is given as here. It is like a winding. It is a winding, right? Here, the voltage applied across the inductor is V of t and the current flowing through the inductor is I of t. And here it is denoted with a capital L or a small l. The unit for inductance is Henry, that is capital H. The basic equation for governing the behavior of an inductor is the Faraday's law of electromagnetism. That is the induced EMF E is equal to minus d phi by dt. When there are n turns in a coil, EMF will be induced in each turn so that the voltage across the coil would be n times larger. So the voltage V is equal to n into d phi by dt. The flux produced in the magnetic circuit is proportional to the current flowing in the coil. So that phi is directly proportional to I. That is flux linkage phi is equal to L into I. We know that. So V is proportional to di by dt. Therefore, V is equal to L into di by dt. And I can be written as I is equal to 1 by L integral V by V into dt. And from this we can also calculate the power in the inductor. P is equal to V into I, that is L into di by dt into I. So it can be also written as d by dt of half Li square. The energy can be derived from this equation, that is E is equal to 1 by 2 Li square joules. The next component is the capacitor. The capacitor are the passive elements that can be used to store the energy in the form of electric field. So here it is the symbol of the capacitor. That is, it is represented with two parallel plates. Okay, so the voltage across the capacitor is V of t and the current flowing through the capacitor is I of t. It is denoted with small c or the capital C. So the unit for this capacitance is Faraday. The stored energy in is of charge. The charge Q is equal to capital C into V. So we know that that is dq by dt is I. I is equal to dq by dt, that is rate of change of charge. From this we can get q is equal to integral I dt. So I dt can be, it is equal to cv, that is equating these two equations. It is I integral I dt is equal to cv. So v is equal to 1 by c integral I dt. From this we can calculate the current, that is I is equal to c into dv by dt. And the power in the capacitor P is equal to V into I, that is equal to CV dV by dt. And the energy in the capacitor is equal to integral Vc dV by dt into dt. dt will get cancelled. So we are having only Vc and dV. So CV dV. So from this integrating this, it is equal to 1 by 2 CV square. So Cv into dV by dt can be written as like this. So that integrating this, we are having the energy is equal to 1 by 2 Cv square joules. So it is the overall summary of this basic components of the circuits. Basic components of this circuits. So here the first one, the resistance, the unit is ohms, and the voltage across the element V is equal to R into I, and the current through the element is equal to I is equal to V by R, and the energy is equal to VIT. The second one, inductor, the unit is Henry, and the voltage across the inductor V is equal to L into di by dt, and the current through the inductor I is equal to 1 by L integral V into dt, and the energy is equal to 1 by 2 Li square. And the third one is the capacitor. The unit for capacitor is the Faraday's F, and the voltage across the capacitor V is equal to 1 by C integral I dt, and the current through the capacitor I is equal to C into dV by dt, and the energy in the capacitor is equal to 1 by 2 CV square. So this is a summary of this one. And next, that is the basic components we discussed. Next one, the energy sources in the electric circuits. We know that the energy sources in the circuits are the voltage source and the current source. So here this is a symbol for voltage source and the current source. In this AC, it is denoted with the sine waveform, and DC, it is denoted with the positive and negative sign. Here the circle denotes the independent source, and the that is the square, that is a diamond shape, it represents the dependent source. So similarly in the current source we are having the direction that is specified in this, and it is the circle, it reflects, it is the independent source, and the diamond shape represents the dependent source. Again, it can be classified into ideal or non-ideal sources. So first we will take the practical voltage source. When we are having the practical voltage source, we have to consider the internal resistance. Let the practical voltage source, the voltage is Vs, and the internal resistance of the voltage source is Rs. We are considering these two. When the voltage is coming out of the voltage source, the internal resistance will that is, it will take away some voltage, it will consume some power. Okay, due to this there is a small voltage drop in the internal resistance of the supply. So that if you see the graph, that is the characteristics here, there is a small dip in the voltage due to this internal resistance. The terminal voltage Vs, that is Vt, across the load changes with change in the load current due to the voltage drop in Rs. The voltage, terminal voltage can be derived as Vt is equal to Vs minus Is Rs. Anyhow, this internal resistance is very small, so that the voltage drop is very, very little. As Is increases, Vt decreases. And the second one is the practical current source. Similar to the current source, here it will drop. Next. Okay, next one is the ideal voltage and current source. So here in ideal condition, the internal resistance of the sources are equal to 0. So there is no need for considering the internal resistance, that is Rs is equal to 0. So there is no drop in the internal resistance. So what is the supply given, supply voltage given, that will be applied across the load terminals. Similarly, in ideal current source, what is the current given by the source, it is applied across the load. Okay, so here the load current will be equal to the supply current. Load voltage is equal to the supply voltage. That is in the ideal case. So next one, the sources can be divided into independent source and dependent source. If the independent source means it will give the supply, that is it may be the voltage or current independently, always it will give the constant voltage or constant current. But a dependent source means it this the voltage delivered by the sources or depends upon the previous operation, or the current given by the supply is depends upon the previous operation. So here first we will take the independent source. The ideal source discussed earlier are independent sources, also termed as uncontrolled sources. The voltage and current are not affected by other parts of the circuit. That is, their voltage and current are fixed. In dependent sources are known as controlled sources. The voltage and current is not fixed. The voltage or current is dependent on voltage or current existing in some other parts of the circuit. There are four types of controlled sources, and this classification depends on whether the control variable is voltage or current and the source controlled is a voltage source or the current source. So here these are the independent and dependent sources. So these are the dependent sources. Here there is four dependent sources. First one is the voltage controlled voltage source VCVS. So here the voltage is depends upon the voltage. So V is equal to K into V1. And the second one is the voltage controlled current source VCCS. Here the output current is controlled by the voltage. Okay, so here I is equal to K into V1. And third one is the current controlled voltage source. Here the current is controlling the output voltage of the source, that is the V is equal to K into I1. And the final one is the current controlled current source. Here the output current depends upon the current, that is supply current. So I is equal to K into I1. So it is the current controlled current source. Okay, now so far we discussed about all the components, circuit components and the sources in the electric circuits. Thank you.